Hello, this is Mr. Wilczewski back again, and this is section 5 of the lesson Advanced Chemical Reactions. We're going to talk about something very interesting called activity series. Now, the ability of an element to react is referred to as the element's activity. Now, the more readily an element reacts with other substances, the greater its activity. Here's an example of an activity series. Notice there's a metal section here and there's a non-metal section. The activity series is just a list of chemicals in order of their activity. It's kind of like a pecking order or an order of who's the strongest. Lithium here, Li, is at the top of this list. It's the most reactive element in this list, and it's stronger than anything above it. That's the basic rule. Any element is stronger than anything that it's stronger than anything below it. I think I reversed that. So lithium is stronger than anything above it. Rubidium is stronger than anything above it, but not stronger than lithium. So an element in an activity series is strong enough that it will replace any other element. So activity series basically deals with the single replacement or displacement reactions. Notice here it's grouped. So these elements between lithium and sodium, they're so reactive that they'll react with cold water and acids, replacing the hydrogen. Those between magnesium and cadmium, they'll react with steam, but not cold water. So they're very reactive, but less reactive than the first set. Then we have this set here from cobalt to lead. They do not react with water, but they will react with acids, and they'll replace the hydrogen in the acid. Then we have hydrogen itself, down to mercury. These react with oxygen, forming oxides. And these last three, silver, platinum, and gold, they're fairly unreactive. They form oxides, but only indirectly and very slowly. That's why we make our jewelry out of gold, silver, and platinum, because it doesn't react, it doesn't rust, it doesn't tarnish as quickly. You make jewelry out of iron, the first time it gets wet, it's going to start to rust. All right, or a copper will oxidize and actually turn green. I've seen people wear copper jewelry, and sometimes it'll actually turn their fingers green. Okay, activity series of metals indicates the ease with which metal atoms lose electrons. Because that's what metals do. They lose electrons. That's how they react. Nonmetals react the opposite way. So the activity series of nonmetals indicates the ease with which nonmetal atoms gain electrons. That's what nonmetals do. They gain electrons. Okay, remember this. If it's lower, it's slower. If it's lower in the activity series, it's less reactive, it's slower. In an activity series is a list of elements organized according to the ease with which these elements undergo certain chemical reactions. So for metals, the greater activity means a greater ease of loss of electrons to form positive ions. So if metal X is lower than metal Y in the activity series, then metal X loses electrons less readily than does metal Y. Alright, for metals, a greater ease of loss of electrons to form positive ions, we said that. I'm driving the point home now. If metal X is lower than metal Y in the activity series, then metal X loses electrons less readily than metal Y. I know I'm repeating myself. I'm trying to drive home a point here. Okay, so here is your activity series. Let's go back to that slide. Just pardon me a second. Bear with me. I want to get to this video here. Okay, there we go. All right. Let's enlarge this so you can see it better.
Activity series is a categorization of elements based on their reactivity. For example, alkali and heavier alkaline earth metals react readily with cold water, oxygen, and acids. Lighter alkaline earth metals, aluminum, and some transition metals will not react with cold water but will still react readily with steam, oxygen, and acids. Some heavier metals will react with acids and oxygen but are unreactive to any sort of water. Other heavier metals will react with oxygen but are inert to acids and water. A few transition metals, such as gold and silver, are very unreactive.
Okay, so if metal A is lower than metal B in the activity series, then metal A loses electrons less readily than does metal B. If copper, Cu, is lower than sodium in the activity series, then metal copper loses electrons less readily than does metal sodium. Okay, in an activity series, any element can replace any element below it in the series. That's the basic rule to remember for activity series. So let's use that. Here we have aluminum reacting with iron nitrate. Well, look at where they are in the activity series. Aluminum is here, and iron is further down. Iron is right here. So aluminum is higher, so it can replace the iron. That's why it forms aluminum nitrate, and the iron is now separate. Okay, finish this sentence. In the above equation, iron has been replaced by aluminum. Okay, whether a certain chemical reaction will occur or not can be predicted using an activity series. So if you have these single displacement reactions, you can predict them using the activity series. So here we have sodium and water. Well, sodium is up here. It's in that section of the table. It reacts with cold water or acid. So yes, you can predict the sodium will replace the hydrogen in water to form sodium hydroxide and hydrogen gas. So yes, you can predict this. Remember, the question we're asking here is, can you predict this reaction? Here's another reaction. We have chlorine and sodium iodide. Well, look at the nonmetals. Chlorine is here, iodine is here. So you should correctly be able to predict that the chlorine would replace the iodine here and form sodium chloride, and the iodine again would be separate. So yes, you can predict this reaction. How about this one? We get chlorine breaking down into chlorine ions. Well, you might predict this, but you can't predict this using activity series because there's nothing to replace anything else. There's just one thing here, two chlorine atoms that are identical. So no, you would not be able to predict that using activity series. Here you have an acid-base reaction. If two things trade in places, you're not going to be able to predict that. It's not a single displacement reaction. Here we have the opposite of the one above. We have two potassium ions coming together to make a two chlorines coming together to make a chlorine molecule. You would not be able to predict that using the activity series. Here we have zinc and hydrochloric acid. Well, zinc is here, right there on the activity series. And it's in that section will it react with acid. So the zinc can replace the hydrogen in hydrochloric acid, form zinc chloride and hydrogen gas. So yes, you'd be able to predict that one. Here's one. You have magnesium bromide. So look at your nonmetals again. Your bromine is here and your chlorine is here. So the chlorine is more reactive than the bromine, so it can replace it, forming magnesium chloride and bromine. So yes, you could predict that. How about this one? You got magnesium chloride now and bromine. Well, chloride is up here, bromine is down here. The bromine is not strong enough to replace the chlorine, so there's no reaction. But can you predict it? Well, I just did. No reaction is a prediction. So yes, you can predict that even though there's no reaction, that is the prediction. Okay, if a certain metal is placed in an ionic solution containing another metal and no reaction occurs, then the metal originally in the solution is higher in the activity series. Okay, that brings us to the end of this chapter on advanced reactions.